Comrades, we are back. Let's see. Hello. Can you hear me? I hope so. Let's check. Let's put on some music. Yeah, I think you can hear me. Alright, let's do this. Okay, what's the goal for today? Let us load up Comfy one? Okay, I'm gonna load up Comfy UI. In the meantime, let's actually do Comfy UI face transfer. It's a use case I'm interested in seeing. How can you do? Actually, I think Stability put out some documentation for style. The service extracts stylistic elements. Okay. The service extracts stylistic elements and uses it to guide the creation of an output image based on the prompt. The result is the control image. Okay. How to use. Should include an image, a prompt, a negative prompt, aspect ratio. Alright, so giving get authorization, accepted request, prompt. Let's see. See. And actually, one of my coworkers put out a comparison a comparison video for different trainers. So let's check this out. So let's do two things. Let's see, control, sketch. Okay, it's interesting. All right, let's see. Where was it? Collab. Let me just take care of this right now. Alright, okay. So what are we doing? We're doing Comfy UI style transfer. Also, let's take a look at what is supposed to be fine-tuning of models within SD3. Also fine-tuning SDXL models. But it's actually just digging deep. I'm going to put this on a faster speed and then listen to this.
That doesn't stop me from exploring SD3 on my own in my free time. You may ask, why even bother working on training this model since there's seemingly no upside? Well, if you've been keeping up with SD3 news, you may have seen that there's been a community license update regarding all Stability AI models here. There's also a promise to improve the existing SD3 2B medium model. In addition, as of today, Stability AI now allows SD3 2B medium models to be uploaded to their website. Sadly, the generation services are not supported. In particular, the Stability AI update stipulates free commercial use if your annual annual revenue is under $1 million US, which is similar to the revenue share structure of Unreal Engine, a tool that I often use in conjunction with my other art software. It sounds like this was proposed by someone who is simultaneously a creative in the entertainment art industry and also an engineer that works closely with generative AI, but this is just my hazardous guess. Anyway, I'll be going over some tried and true tools such as Koyo's ST scripts, in addition to some new ones like Simple Tuner. So this is sort of an update to my STXL training process and could be useful information even if you aren't going to use ST3 at all. As always, the settings and workflows that I use will be available on my GitHub. At this point, I want to notify you about a few things in advance regarding this video. Firstly, training repositories often change, so it's completely possible that by the time this video comes out, the setup or configuration may look a little bit different. However, the training settings should be processed the same under the hood. Secondly, I was unable to hone in and finalize the best Koyo ST script training settings, but it seems like it should be somewhere between 9 times 10 to the negative 5 and 1.5 times 10 to the negative 4. If you aren't a Koyo ST script user at all and don't want to learn how to use the ST3 branch, I suggest that you skip most of the first part, but watch the very end of it to see if you like the results there. Then head straight to the following Simple Tuner part as I did get decent results with that repository. You can save time this way and see which styles you like the most. Let's get started. The way I approached training ST3 was to first see what tools were available to the public. Stability AI has their own in-house tools to train ST3, and we obviously don't have access to those. A few hours after ST3 Medium was released, the very first training repository that was available appeared from Diffusers by Hugging Face. You're free to use this, but I didn't try that much because I was traveling during that time. According to this article here, and clicking on this link, it supports both full fine-tuning and lower training. In the acknowledgements section, for some reason, Hugging Face got Stable DIffusion 3 early access, and none of the other well-known training repositories got it, which is kind of weird. But anyway, the second tool that became widely available was Simple Tuner by Gira. If you head over to his repository here, you can see that there is no ST3 branch, which means it has been merged into the main repository, which is great. To see how to do ST3 training, you can go to documentation, and then in here there should be a quick start, and then an ST3 markdown file. In here, it'll tell you all that you need to do to get it set up, or you can watch what I do later in the video. It's up to you. Simple Tuner was what I ultimately chose in the end because it gave me the best results. This repository supports both full fine-tuning and lore training as evidenced by this stxl env.sh.example file. Click on it and go over to here. There's export model type either LoRa, because it gave me the best results. This repository supports both full fine-tuning and lore training as evidenced by this stxl env.sh.example file. Click on it and go over to here. There's export model type either LoRa or whole. So there you go. The third tool that I know of which added support for ST3 fine-tuning was Koyo's ST scripts, a beloved favorite of the community. It does not yet have ST3 merged into the main branch, so to access it you have to click on that branch. As such, it's still very experimental. I did not get good results using this repository, but I did use it to acquire the ballpark estimate of learning rate with the Prodigy Optimizer. The ST3 branch only supports full fine-tuning for now, and even that doesn't seem to actually work. I deduced this by going through the code and also seeing that there's an ST3_train, but there's no ST3_train network, which is usually what you use for LoRa. If you don't believe me, the proof is right here in this train stxl markdown file. stxl train network.py is a script for LoRa training for stxl, and stxl_train with no network is a script for stxl fine-tuning. The final tool that I know of is OneTrainer by NeuroGar, which seems to have an ST3 branch. However, setting up the command line requires you to first get the training script from the graphical interface. In particular, this is a pain point for me since GUIs are just visual interference and open you up for a lot of mistakes. If you go to Issues and search for ST3, I assume it's working because there are some people successfully getting errors when training, so feel free to use this if you want. Normally, I would just start plugging in random values for the learning rate to get to a base threshold value as to not explode the gradient. However, since Koyo's ST3 branch supports full fine-tuning and the Prodigy Optimizer, I just use that to approximate the learning rate. If you're up to date with Koyo's ST scripts repository, then you are already aware of it switching to this .toml file format instead of config.json. Before I show you the configuration, let's first set up the environment. On the main page of Koya's ST scripts, make sure it's on main, go to code, and then copy this HTTPS get URL. Like that. I'll be using Windows for subsystem Linux 2 because I want to ensure the closest compatibility. You can try doing this with Windows. Your mileage may vary, it might fail, so I'm just going to keep it easy. And I'm using Ubuntu 20.04. Make sure you prepare the workspace. I'm just going to use the standard home folder, so tilde, and remember the URL we copied. Go ahead and type in git clone, and then paste in that. So it's going to clone it into ST scripts. Should be pretty fast. Now cd ST scripts like that. However, if we do git branch, we're on main, and we don't have ST3 branch here. However, we can go ahead and check all the remote branches by typing in git branch, and then -a. And the one that we want is origin ST3, so we can just check that out from the remote. Type in git, check out -b, ST3, and then origin ST3. If you're not confident, you can always just copy paste it. So now that you do this, go to git branch, and we're on the ST3 branch already. Do git checkout to go back to main if you want, and yes. Pretty easy. Once you're here, I suggest you to set up a virtual environment. What I do is use pynv to set up the correct version of Python. You can see that I've already set up version 3.10.6. If you're starting fresh, you'll just have system, and you'll need to install a correct version of Python with pynv install followed by the version number. I'm not going to do so because I already have it. However, it's stuck on system, which we don't want. To change the Python version for a specific directory, we can use this command called pynv local followed by the version number. So like that. And if we run versions again, inside this ST scripts, you can see that it's set to 3.10.6 for this directory. You might ask, how do I know that this is the right version of Python that I need? If you go over to the repository and look at the README file down here, it says required dependencies and Python 3.10.6. Now that we have the correct version of Python, all we have to do is create a virtual environment with this command. I've already done so there's no point in me doing it. Then to activate it, type in source, cmd, bin, activate, like that. Now that we have our virtual environment, all we have to do is set up the dependencies, so just follow the instructions on the README. I'm using CUDA 12, Intel by NVIDIA SMI right here, and I'm on the 12x version and not 11x. So I'll be using this one, right? Wait for that to finish. Now that Torch and Torch Vision have been installed, go ahead and install the...
Actually brings up a good question. Even before that, you know, what are LoRa's? LoRa, Stable DIffusion. Okay.
Hello everyone. Today I want to give you a quick introduction to LoRa models. Together we are going to see what they are, how to activate them on Stable DIffusion, and how to use them. LoRa models.
So I'm thinking what we'll do today is watch some videos on tutorials and try to implement some. I'm trying to get a sense of ST3 fine-tuning. That's the main task, but that also means I have to kind of backfill some theory. So I'm focusing today on two things. Number one is LoRa models. Number two, most likely the first half hour of this Stable DIffusion, the course from Fast AI. That's what's on the docket for today.
Are fine-tuned models which allow you to generate images based on a particular style, a specific character, or object. And if you look at Stable AI, which is where you can find most of the models, you will see that you have here on top right a filter where you can have a look at different model types, and you have checkpoint and you have LoRa. So if we filter for LoRa, I don't know, maybe Stable DIffusion 1.5, you can see that there are different types of LoRa models. And then on top here, you can filter as well for style, concept, of the 1.5.
Just going back, restarting to those.
Hello everyone. Today I want to give you a quick introduction to LoRa models. Together we are going to see what they are, how to activate them on Stable DIffusion, and how to use them. LoRa models are fine-tuned models which allow you to generate images based on a particular style, a specific character, or object. And if you look at Stable AI, which is where you can find most of the models, you will see that you have here on top right a filter where you can have a look at different model types, and you have checkpoint and you have LoRa. So if we filter for LoRa, I don't know, maybe Stable Diffusion 1.5, you can see that there are different type of LoRa models. And then on top here, you can filter as well for style, concept, clothing, cars, and so on and so forth. LoRa stands for low rank adaptation, and it's a cool technique for fine-tuning Stable Diffusion models. Now, there are other training techniques.
Okay, just give me a second. I just realized I should be taking notes. I'm just going to grab my iPad. Alright, we're good. Just gonna take some notes, because usually when I'm taking notes it helps me learn better. Just going to take some notes on my Notability app. I don't think you need to see this, so I'll just keep it here. Let's create a new folder. Shit, just give me a second. Need to log into my account. So I haven't logged into it for probably about a month. Need to turn on my active backups. Get my code. Is anyone using LinkedIn Premium still? Interesting. Weird. Alright, stupid code is not coming. There we go, just came through. Okay, going to create a new AI. Just going to create a new subject and call it Stable Diffusion. To move it just underneath it. Sorry, it's just requiring a lot of manual work, like setting up templates, etc. You know what, I'm just gonna go with a blank template. So low. Now I hate it. I'm just switching it out to those Cornell templates. I hate them. They're so ugly looking because of the design that they're done. Wish there was an easier, better template. Maybe I should make one. It doesn't suck ass. Cornell node, apply. Alright, bro. Let me just make a... Okay, we're learning about... Okay. Here we go. Learning about low rank adaptation. Adaptation, can't spell. Or LoRa models. Okay.
Like rainbow
Don't ask a Punjabi what LoRa means.
or text inversion, but they can be computationally expensive, like Dreambook, for example, and the quality of the image generated is not always the best. And that's where LoRa comes in. Why? Because LoRa for fine-tuning Stable Diffusion models. Now, there are other training techniques like Dreamboat or taxon inversion, but they can be computationally expensive, like Dreamboat, for example, and the quality of the image generated is not always the best. And that's where LoRa comes in. Why? Because LoRa models are way smaller than normal checkpoints, normal models, and the image quality they produce is stunning. So again, let's go into CVDI. We can see, like, look at this example. This is a LoRa model. You can see type LoRa here, and you will see here download. You just have 145 megabytes. But if you look at a normal checkpoint, so let's filter for checkpoint. Okay, let's see this one. You will see that you have 5.5 gigabytes.
Oh wow.
So yeah, the LoRa model is way smaller, right? So how does it work? So when you're training with LoRa technique, basically the fine-tuning doesn't happen on the full model, but just on a little part of the model, which is the cross-attention layer. And this little part, although it doesn't work, so when you're training with LoRa technique, basically the fine-tuning doesn't happen on the full model, but just on a little part of the model, which is the cross-attention layer.
Aha, okay. Okay, so in LoRa, so it happens on the cross-attention layer, not the whole model. That is great to know. See, this is what I like about
And
learning.
this little part, although it's a small part of the model, it's really important and it seems to have a huge impact on the image quality. The cross-attention layer is the part where the prompt and the image meet. What is important to know is that thanks to LoRa technique, the number of parameters trainable is reduced, right? And this means that also the GPU requirements are less. So that's why you have a lower size model, which is even quicker to train. The only downside, which in reality is not really a downside, is that you cannot use LoRa models by themselves alone. You always need to use them in connection with another model, like for example Stable Diffusion 1.5, or maybe better, there is another model, you can find that on CVDI, which is called any model. Actually, we can have a look at this together. So if we search any LoRa checkpoint, which is a specific model trained to make sure that any LoRa will work with that. I'm going to show you the difference between using Stable Diffusion 1.5 and this any LoRa checkpoint, and you will see probably a huge difference. But as usual, this is very subjective, so it's up to you what you want to use and what you prefer. So how to activate LoRa into Stable Diffusion? In the past, well, not really in the past, but like last month or 2 months ago, we had to activate LoRa going into the extension tab and activating, like installing the extension. But as of today, likely, we don't have to do that anymore, and you should find LoRa already in your Stable Diffusion when you initialize it, which is amazing, right? So in reality, we don't have to do anything but downloading the models. So where you can find these LoRa models? You can find them on Hugging Face. If you go in here, you have a long list of LoRa models trained, fine-tuned by other people, or CVDI. And something that I really like of CVDI is that I just picked one LoRa model, which is Studio Ghibli style, which I really like. And if you go on this eye at the bottom right of the picture, you see all of the settings used for getting this picture here. So we're gonna test this together and see if it actually works. And something that you should know as well here, you have important settings. So you have the details of this model, and it's telling you the type, which is LoRa. It's telling you when this was uploaded. It's very important if you're looking for the latest version of the model. The trigger word. This is super important because this is the word you need to use in your prompt. And if you don't use this word, in this case it's Ghibli style, you're not gonna have the effect you would like to have from the model. You cannot exploit the model well. In addition to that, we need to also recall the LoRa model inside the prompt, and we'll see together how to do that. So to download the LoRa model, it's quite easy. You just press on the download button, and as well when you go into Hugging Face, you just need to press on the download button for the LoRa model, which usually is a safe tensor. The download should be pretty quick because the LoRa model is very small, and once you download it, it should go into your downloads folder. So what we have to do now, we need to just move or copy and paste or cut and paste the safe tensor we just downloaded into our Stable Diffusion Web UI folder. Let's have a look which folder we need to use for the LoRa model. So this is my Stable Diffusion Web UI. You need to go inside Models, and then here you will see you have different folders, and you have LoRa. You click here, and here, let me clean it a little bit because it's horrible, so clean up by name. And then here we need to move this file inside the LoRa folder. So I'm just gonna do that. That's it. I can close my download folder, and here you go. So just to have a look again where it is, like this. So you go into your Stable Diffusion Web UI, Models, LoRa, and inside here you need to have all of your LoRa models. Pay attention because usually you put your checkpoints, your full models inside Stable Diffusion, which is in here. But if you put your LoRa model inside here, your LoRa model is not going to work. So make sure that you paste that inside your LoRa folder. Yeah? And if you're using Google Drive, if you're using the drive, an external drive, make sure you're using exactly the same folder. The path to the folder is exactly the same. So Stable Diffusion Web UI, Models, LoRa. Easy. Okay, let's go into Stable Diffusion now. On top here, on top left, you can see all of the models available. These are not LoRa models. Here you won't find LoRa model, but just the full model, like for example, Stable Diffusion version 1.5, which is in my case this one. But given that I want to use a LoRa model, I'm going to use this any LoRa checkpoint I was showing you before, because it usually works better with LoRa models. It's made exactly for that. So I'm going to use this one, and where we can pick our LoRa models. So you see here you have this little button under the Generate button. You can click on it, and then a tab, like different tabs will appear. So you have textual inversion, hypernetwork, checkpoints, and LoRa, where you can see all of the models you have now. I don't have textual inversion or hypernetwork, so I'm going directly into LoRa. And inside this tab, you will see all of your LoRa models. Now, the one I want to use is this Ghibli style offset. So what you can do, you can just click on it, and then what happens is that here will appear a small text which is LoRa Ghibli style offset 1 in your prompt, positive prompt. Now, every time you want to use a LoRa model, you need to write this piece of text. And in addition to that, you will need to write the word specified in the model description. In the case of the Ghibli style, the word was Ghibli style. Yeah? So I'm going to copy this, and I can go back onto my Stable Diffusion, and I'm going to paste it like this. And then I'm going to write my prompt, etc., etc. Now, what I want to tell you about this text. So the format of this has to be exactly this one. It doesn't matter where you put it, but it has to be exactly this one. So you have LoRa, column, and then you have the name of the model, which has to be exactly the same as the name of the model you downloaded. If we go into our LoRa folder inside Stable Diffusion Web UI, you will see that this is my LoRa model, and then part of the name you need to get is exactly this one, so Ghibli style offset. You don't have to add .save tensors, you just need to copy and paste this part. And then you have this one here. There are different names for defining this. It's weights, multiplier, alpha. This is a number that usually go from 0 to 1. Sometimes you can find 1.7, 1.1 or something like that. What is it? So if you set it to 0, it means you are not using your raw model. Basically, you're not using it, but you're just using the, this model here you picked. If you give 1, it means you're giving full weight to your raw model. So usually when you go into Stable AI, they tell you which is the minimum weight you should be using for that specific style, and then you can play with that. So for example, in this Ghibli style, they tell you this is good around 1 weight for the offset version and 0.65 for the old one. So you see they're telling you which weight you should be using, which is great. Now, you have 3 different ways of writing this piece of text. You don't have to remember it. So first you can write it by doing what I just did, so clicking on this button and then picking the LoRa that you want to use. Let me close this now. Otherwise, what you can do, you can go inside Stable AI, model details, and then, I don't know, for example, if you want to reproduce this picture here, you see you have this eye I showed you before. You can copy generation data, or you can also, like if you look at in here, you have the what you should be writing in your prompt in here. This is your positive prompt, and this is your negative prompt, and these are other settings. But if you copy generation data, it should give you all of these settings, not just those. And then you go back into your Stable Diffusion, and you paste what you just copied in here in your positive prompt. And then you can click this little button below the generate button. And like magic, all of these settings will apply to your Stable Diffusion. And you can see here you have this name to recall the LoRa model, and you have this Ghibli style trigger word, which is really important. Just to show you, like, obviously here you have different examples of pictures, and if you click on all of them, you will see that this Ghibli style is recurring in all of them. Because, as I said before, this is the trigger word, so you actually have to use that for reproducing this particular style. So ideally, when you do this, it should work. Sometimes it can happen that they upgrade or they modify something in the model and they change the name of the file, but they don't change it in here. So sometimes when you do this copy generation data and you paste it in here, it can be that this is not exactly as the model name you have downloaded. So in that case, you need, like if something doesn't work, if it gives you an error, right, you just need to double check that the file name is exactly the same as the one downloaded. So this was the second option. And the third option is writing it manually. Also in that case, we are human and we can make mistakes, so it can be that sometimes we write the wrong name, so just make sure it's exactly the same, and also that there are no spaces between words. So in this case, you see you have 1.07 as weight, although 1 should be the maximum. Ideally. Anyway, I'm using this Ghibli style LoRa model. I'm using the any LoRa model checkpoint. I copied and pasted the settings from Stable AI to here for this picture here. So when I'm going to press the generate button, ideally I'm expecting to get something similar to this picture. Let's see if this is the case. So we go here, we press generate. Oh, it's giving me an error, so it says could not find auxiliary name RESR done anime video. That's fine. I don't need to use the high resolution for now, so I can remove it. So it's something related to upscaling the picture, right? So I can untick this high resolution here, and then I'm just going to press generate again. Now it's working, and wow, like magic. We got this picture, which is probably not exactly the same as the one we have in here, but really similar, right? So that's how you use the LoRa model. Now, let's have a look if we change to, I just want to show you like the difference between using this model, which is any LoRa checkpoint, compared to using Stable Diffusion 1.5, which should work anyway because it's the Stable Diffusion model used for training this Studio Ghibli. Let's press generate again, let's see what happens. Yeah, and you see that you don't get the same effect at all. So what is this? Training this Studio Ghibli. Let's press generate again, let's see what happens.
Oh, she changed the diffusion
and you see that
checkpoint.
you don't get the
Okay.
same effect at all. So what is this? Let's have a look. Yeah, definitely not. I would suggest you to try different models if you wish, but in my case I'm going to use this any LoRa checkpoint for this tutorial. Now, ideally, what we can do to use this style on something else, like if you don't want to produce this picture, right, but you want to generate something different but still applying the same Studio Ghibli style, we can maybe, I don't know, change something here. Maybe I want to remove all of this. I don't want a person, maybe let's try with an animal. I don't know if this is gonna happen, but let's try. So we can maybe generate a cat sitting in the forest, and then I don't know, we can put something, some additional feature just to very detailed. Okay, let's keep this, yeah? Only just to see if something happens. Okay, and now I didn't give many information to my Stable Diffusion, but as you can see, the Studio Ghibli style has been applied, which is amazing. And instead of having the woman, now I have this little black cat, which is really cute, even though he has 3 tails, apparently. But yes, in this case, we need to work maybe a little bit more on the prompt, both positive and negative prompt, and regarding the other settings, I'm quite happy with that. Something very important, I think, is the seed as well. But in general, it's more important when you want to recreate exactly the same picture, like make sure that the seed is exactly the same, right? And in this case, the seed is this one. I can use a random seed. Let's see what happens. Maybe something will change. Let's press generate again. But hopefully we'll still get the same Studio Ghibli style. And we indeed do, and probably this is even nicer because it seems more realistic and it's quite nice. So something very cool you can do as well, you can combine different LoRa styles. And this is when you want to, have a merge between a different style, or if you want a Ghibli style, but mixed maybe with some person, some character, right? So let's have a look at an example. Let's have a look at some celebrity, maybe we can use the most downloaded, or highest rated, maybe better.
That's the image of Alexandria Daddario.
Here, Alexandra Daddario. So I can download this model, right? I'm gonna move the model inside my Stable Diffusion again folder. I'm using Windows now because Stable Diffusion on my Mac was really slow and Colab wasn't working properly today, so I had some issues. I'm using Windows. So you would see a little bit of a different background, but the steps you need to follow are exactly the same. And I'm going to restart my Stable Diffusion. So I have the terminal here, and I'm going to quit this, and I'm going to restart it again. Okay, I restarted it. I'm going to refresh the page. Okay, now if we go into this button again, we should see the new model I just downloaded. Let's go a little bit down. Both the new LoRa model, so I'm gonna press on both of them, so that should, the text should appear here. And then we need to add, the trigger word, which in the case of the Ghibli style is Ghibli style. And in the case of this lady, I'm not sure which one it is. Let's have a look. Both the new LoRa model, so I'm gonna press on both of them, so that should, the text should appear here. And then we need to add, the trigger word, which in the case of the Ghibli style is Ghibli style. And in the case of this lady, I'm not sure which one it is. Let's have a look. So it's Alexandra, cool. And then this is the trigger word. So Alexandra, I'm gonna take it, going on Stable Diffusion, I'm gonna add this in here so I don't forget. And then you can start building your prompt. Ideally, and I'm saying ideally, the sum of the weight of the two neural models should be equal to 1. So if you give 0.8 to 1, it should be 0.2 on the other side, and if you give 0.6, it should be 0.4, and the other way around. So obviously it works even if you use 1 and 1, or it just means you're giving the same weight to both. If you use 0 for 1, it means that you're not using the one with the 0, but you're using the other one. So yeah, like just keep this in mind. Let's, for example, put, I don't know, choose 0.8 for 1, or 0.5 and 0.5 for both, which is exactly the same of using 1 and 1. Is just for giving you an example where the sum of that should be equal to 1. This is obviously like we'll need more from description and also negative run. This is just for showing you how it works, and then you press generate, and you should get a mix of these two, right? So this is what we get. Let me open it. So it's kind of like this lady, right? And the Studio Ghibli style is here, which is great. And then, I don't know if you're not happy with that, but you would like to have something still more looking like you can increase the weight of the Alexandra the value weight. So here, I don't know, you can put 0.8, 0.9. For example, and here you can use 0.2.
This is a very good video.
You should get something similar. Obviously, you can use more than 2 neural models. You can use 3, 4, 5, how many you want. You can mix them, play with them.
That's a really good video. Glad I watched that. Alright, this is really good.
Hello.
So I subscribe to her. Okay. Not exactly what I'm looking for. Looking for very basic information. Oh, actually, it's a good point. Let's put on some music while we go about doing some research. Let's do AI tools, perplexity. Alright. We're going to do that is a LoRa model. Okay. Tailored for defining stable diffusion models, offering a good trade-off between file size and training power. Not be used alone and must be used. So this is all the stuff that we learned in this video. The significance of LoRa model lies in striking the favorable balance between file size and training effectiveness. LoRa is a type of parameter efficient fine-tuning method of researcher. Fine-tuning large language model diffusion models. Okay. What are diffusion models? Diffusion models are a type of a generative model that use a process called diffusion to generate data. The diffusion process involves adding noise to a data set and then learning to reverse this process to recover the original data. The process is repeated multiple times with the model learning to denoise the data at each step. Okay, so it seems that from backpropagation, the differences here are forward process, which includes adding noise to a data set to create a corrupted version of the data. Reverse process. The reverse process involves using a neural network to learn the denoising process and recover the original data. Sampling process involves using the learned denoising process to generate new sample from data set. Type of diffusion models. Denoising diffusion probabilistic models. The improved denoising diffusion Probabilistic models. Guided diffusion models. Image generation, image to image translation, text to image generation. Okay, what was this video?
Hello everyone, today I want to give you a quick introduction to LoRa models.
Oh, this is the video we watched. Okay, cool. I think we can just straight up jump into this lecture that I was talking about. Where did that go? Right here. Let's pause this right here. Okay, sorry, I was just answering something. Where were we? Alright, let's see. So this is the Fast AI website. Alright, let's just jump in. Let's not wait any longer.
Hi everybody, and welcome to Deep Learning Foundations to Stable Diffusion. Hopefully it's not too confusing that this is described here as Lesson 9. That's because, strictly speaking, we treat this as Part 2 of the Practical Deep Learning for Coders series. So that Part 1 had 8 lessons, so this is Lesson 9. But don't worry, you didn't miss anything. It's the first lesson of Part 2, which is called Deep Learning Foundations through Stable Diffusion. And maybe rather than calling it practical deep learning for coders, we should call this impractical deep learning for coders, in the sense that we...
Just give me a minute. I'm just creating a new notebook for myself. The unsexy stuff. So, deep learning foundations to stable Okay.
We are certainly not going to be spending all of our time seeing exactly how to do important things with deep learning, but we'll be doing a whole lot of fun things, generative modelly fun things, and also a whole lot of understanding lots of details which you won't necessarily need to know to use this stuff. But if you want to become a researcher, or if you want to put something in production which has got some kind of complex customization requirements, stuff like that, then it is going to be very helpful to learn the details we'll be talking about. So here in lesson 9, there's kind of going to be 2 parts to it. One is just a quick run-through, quick-ish run-through of using Stable Diffusion, because we're all going to play with it, right? And then the other thing that I'll be doing is describing in some detail what's going on, how's it working. There'll be a whole lot of hand-waving either way, because it's going to take us a few lessons to describe everything from scratch. But hopefully, you'll feel like you come away with this lesson with a reasonable, intuitive understanding at least of how this is all working. Assumptions. Well, I'm going to try to explain everything, everything. I'm going to try to explain everything. So, if you haven't done deep learning before, this is going to be very hard, but I will at least be trying to say, this is roughly what's going on and where you can find out more. Having said that, I would strongly suggest doing part 1 before doing this course, unless you really want to throw yourself into the deep end and give yourself quite a test. But if you haven't done part 1 of practical deep learning coders, you're reasonably comfortable with deep learning basics. You could write a basic SGD loop in Python, and you know how to use ideally PyTorch, TensorFlow is probably okay as well, and you kind of know the basic ideas of how to create, what an embedding is, and you create those from scratch, stuff like that. You'll probably be fine. Generally speaking, these courses, I find most people tend to watch the videos a few times, not on the second time through, but pause, look things up if they don't know, and check things out. Generally speaking, we expect people to be spending about 10 hours work on each video. Having said that, some people spend a hell of a lot more and go very deep. Some people spend a whole year, sabbatical, studying practical deep learning coders in order to really fully understand everything. So it really is up to you as to how deep you go. Okay. So with that said, let's jump into it. And as I said, the first part we're going to be playing around with Stable Diffusion, and I, try to, prepare this as late as possible, so it wouldn't be out of date. Unfortunately, as of 12 hours ago, it is now out of date. And this is one of the big issues with the bit I'm about to describe, which is how to play with Stable Diffusion, exactly how the details work, which is it's moving so quickly that all of the details I'm going to describe to you today, all of the software I'm going to show you today, by the time you watch this, if you're watching it, so what is it up to now? It's 11th of October. So if you're watching this in December of 2022 or watching this in 2023, the details will have changed. So what's happened today in the last 24 hours is 2 papers have come out. So what I was going to be telling you today is, for example, to do with Stable Diffusion generative model, the number of steps required has gone down from 1,000 to about 40 or 50. But then as of last night, papers just come out saying down to 4, and it's 256 times faster. And then another paper has come out with a separate, I think, orthogonal approach, which makes it another, let's see, 10 to 20 times faster. So things are very exciting. Things are moving very quickly. Now, having said that, don't worry, because after this lesson, we're going to be going from the foundations, which means we're going to be learning all the things of how these are built up, and those don't change much at all. And in fact, a lot of what we'll be seeing is extremely similar to another course we did in 2019, because the foundations don't change. Once you know the foundations, these kinds of details about you'll find in these papers, you'll be like, oh, I see, they did all these things the same way as usual, and they made this little change. So that's why we do things from the foundations, so that you can keep up with the research, do your own research, by taking advantage of this foundational knowledge, which all these papers are building on top of. So anyway, I guess I should apologise that even as I record this, the notebook is now 1 day out of date. So in part 1, you remember we saw this stuff with DALI-2 illustrations with cryptodios, which is really pretty cool. So the cool thing is that now we can build this stuff ourselves and run this stuff ourselves. We're actually doing using a different model, DALI-2 will use a different model, Stable DIffusion, has very similar kind of outputs. But we can go even further now. So one of our wonderful alumni, Alan, actually recently started a new company called Drummer, where you can use something we'll be learning about today, called Dream Booth, to put any object, person, whatever, into an image. And so he was kind enough to do a quick Dream Booth run for me and add these various pictures of me using his service. So here's a fun service you can try. One crazy one you try is Lears of the Wharf, which I've got to say actually worked pretty well. This half looks like Lear, I reckon, and then the bottom of it is the dwarf version. So thank you, Alon, and congratulations on your great progress since completing the course. Yeah, I love it. So, something that's a bit different about this compared to previous courses, a lot of previous courses, is this is no longer just a me thing, because this is moving so quickly. I needed to get a lot of help to even vaguely get up to date and stay up to date. So everything I'll be showing you today is very heavily influenced by extremely high levels of input from these amazing folks, all of whom are AI alumni. So Jonathan Bridiger, who I saw in our chat, was basically the first guy to create detailed educational material about Stable DIffusion, and has been in the generative model space for a long time by Stable DIffusion standards, I guess. So Wasim has been an extraordinary contributor to all things fast AI. Pedro came to San Francisco for the last time to do the Part 2 course in 2019, and took what he learned there and made his amazing Camera Plus software dramatically better, and highlighted by Apple with the extraordinary machine learning stuff added. He's now working on the software that we'll be using a lot for users. And then Tadish, everybody in the forum, the Fast AI community probably already knows, now at Stability AI, working on Stable DIffusion models. His expertise includes in medical applications. So really, folks from all the key groups, pretty much, around Stable DIffusion and stuff are working on this together. And you'll also find some of these folks have recorded additional videos going into more detail about some of the areas which you'll find on the course website. So make sure you go to course.fast.ai to get all the information.
Is it using Windows?
Website.
Oh no, he's using this on Mac.
On the course website. So make sure you go to course.fast.ai to get all the information about all the materials that you need to take full advantage of this. So every lesson has links to notebooks and details and so forth. If you want to go even deeper, head over to forums.fast.ai into the Part 2 2022 category, hit on the About the Course button, and you'll find that every lesson there's a chat with even more stuff. So look at this carefully to see all the things that me and the community have provided to you to help you understand this video. And also check out the questions underneath and answers underneath to see what people talk about. They can get a bit overwhelming. So once they get big enough, you'll see that there's a summarize button that you can click to kind of see just the most liked parts. So that can be very helpful. Okay, so they're all important resources I think to get the most out of this course. Now, compute. So completing part 2 requires quite a bit more compute than part 1. Compute options are changing rapidly, and to be honest, the main reason for that is because of the huge popularity of Stable Diffusion. Everybody's taken to using Colab for Stable Diffusion, and Colab's response has been to start charging by the hour for most usage. So you may well find if you're a Colab user, we still love Colab. You may find that you run out of, they start not giving you these GPUs anymore. And if you want to then upgrade, they limit quite a lot how many hours you can use. So at the moment, yeah, still try Colab. They're pretty good. I mean, for free, you get some decent stuff. But I would strongly suggest trying also Space Gradient. You can pay like $9 a month to actually get some pretty good GPUs there at the moment, or pay a bit more to get the better ones. Again, the thing is, this is all going to change a lot. I don't know, maybe people will make that Space Gradient have to change their pricing too. I don't know. So check Core Stuff today to find out what our current recommendations are. Now, Lambda Labs and Java's Labs also both got options. Java's was created by Alarm, of course, and has some just really fantastic options at a very reasonable price. And a lot of AI students use them and love them. And also check out Lambda Labs, who are the most recent provider on this page, and they are rapidly adding new features. The reason
Back in a minute.
At least as I say this, because they say it's early October 2022, they're the cheapest of big GPUs you might want to use to run like serious models. So they're absolutely, well worth checking out. As I say, it's all changed by the time you want it. Go check out AI. Also, at the moment, like 2022, GPU prices have come down a lot, and you may well want to consider buying your own machine at this point. Okay, so what we're going to do is jump into the notebooks. And so there's a repo that we linked to called Diffusion NDs, which isn't kind of the main course notebooks, it's not from the foundation notebooks, it's just a couple of notebooks that you might want to play with. A bit of fun stuff to try out. One of the interesting things here is Jonathan Whittaker, who I can call Jonathan, but Jonathan has got a really interesting thing called Gesture Tools MD, which hopefully he'll keep up to date, so even when we come here later, he'll still be up to date. Because he knows so much about this area, he's been able to pull out some of the best stuff out there for just starting to play. And I think it's actually important to play, because that way you can really understand what capabilities are and what constraints are, so that then you can think about like, well, what we do with that, and also like, what kind of research opportunities.
Interesting. There you go. Don't think he has kept it up. This was updated 2 years ago. Jonathan Whittaker. I don't have an X account, Twitter account. Oh. This is a free Hugging Diffusion course. It just led me back to the actual thing I was already doing. Let's subscribe to this. I think this is probably already done. Interesting. See what else is here. Here we go. Come back to it.
So I strongly suggest trying out these things. The community on the whole has moved towards making things available as photo notebooks. So if I click example on this one, the forum, and they like have this kind of hacker aesthetic around them, which is kind of, and they like have this kind of hacker, around them, which is kind of fun. So what happens is like they add lots and lots of features, and you can basically just fill in this stuff to try things. And they'll have a few examples. And so you can pick up the runtime and say change runtime type, make sure it says GPU, and you can say what type of GPU, and start running things. Now, a lot of folks who use this stuff honestly have no idea what any of these things mean. Now, by the end of the course, you'll know what all of these things mean, pretty much. And that will help you to make great outputs and stuff like this. But you can create great outputs just using more of an artisanal approach, lots of information online about, what kind of things you try. So anyway, check out this stuff from Jono. And then he also links to this fantastic resource from Farmer Psychotic, which is a rather overwhelming list of things to play with. Now again, maybe by the time you watch this has all changed. But I just want you to know these kind of things are out there, and they're basically like ready to go applications you can start playing. So play a lot. What you'll find is that most of them, at least at the moment, expect you to input some text to say what you want to get a picture of. It turns out that, as we'll learn in detail why, the text you pick, it's not very easy to know what to write, and it gives kind of interesting results. At the moment, it's quite an artisanal thing to understand what to write, and the best way to learn what to write is called the prompt. The best way to learn about prompts is to look at other people's prompts and their outputs. So at the moment, perhaps the best way to do that is Lexica, which has lots and lots of really interesting outputs, and so AI outputs. And so you can click on one and see what prompts you use. And so you'll...
Let's see if that is still the best one. Oh, I don't think we need to generate a new thread. We can just do it. What are the best websites? Look at AI generated images. Prompts to learn from them. Okay. Meanwhile, I'm just going to check Stable Artisan. Okay, let's see. OpenArt, I have tried it. So I think OpenArt. All right. Gaza FM, interesting name. But I can't see the prompt here, that's the thing. Within Lexica, let's see, when was this created? This is a mid-journey prompt, isn't it? Hmm. That's interesting. This is so stupid. If they don't actually search by prompt, let's see. Oh, okay. All right. I'm being a dumbass. All right. Let's filter by stable. Let's do Stable Diffusion 3, what people are generating with it. The fingers being the issue for sure. It's doing too much in this prompt. Doesn't need to do all of these things. Interesting. I like this quite a lot. Let's see what is some striking imagery. Oh, this is interesting. See, hands are the issue still. It's not unbelievable, but overall the image seems interesting. I'm fucking talking on mute. Palace maids, elegant and royal, delicate. Yeah, you don't need to say detailed that many fucking times. 4K, HD, give it a camera lens. That's all you need. Fuck England. What about this? Create a series. You don't need to say create. Alright, don't say this. You're wasting words, it's not adding anything. So a series is digital, and your prompt doesn't need to be this fucking long. But let's see. It should calm, contemplative, central focus. A large ancient tree with a hollow trunk. Inside the trunk, place a person in meditative pose surrounded by soft glowing light. Branches. That's interesting. The tree's branches. This is actually really good. I'm going to bookmark this. The tree's branches extend across the entire image, forming intricate patterns. Some branches carry leaves made of tiny screens or mirrors. Tiny screens or mirrors. Visible beneath the ground, their roots. This is actually really good. Hey, what is this? Create a video for my WordPress e-cock. This is fucking bullshit. Interesting. All right. Wait, sorry, we're getting distracted. Let's go back to our.
See here that generally you start with what do you want to make a picture of, what's the style, and then the trick is to add a bunch of like artists' names or places they put art so that the algorithm will tend to create a piece which matches art, that tend to have these kinds of words in their captions. So there's a really useful trick to kind of get rid of this. And so you can search things. So I don't have 10 minutes. Sorry.
You gotta take a call. I'll be right back. Sorry. Let's try to get to the 30-minute mark, and then we'll call it a night for today.
There we go. So there's kind of like a
So we did go through Lexica, and it's good. But OpenArt seems to do even better. Okay, interesting. Generated a pretty good image. Hey, I like this.
That's a pretty good TDR image. So you can kind of get some sense of how to create nice TDR images. It's so cute. I know I'm going to be showing my daughter tomorrow. You can see they often tend to have similar kinds of stuff to try to encourage the algorithm to give good outputs. Okay, so by the end of this course, you'll understand why this is happening, why these kinds of prompts create these kind of outputs, and also how you can go beyond just creating prompts to actually building innovative new things with new data types. Okay. So let's take a look at the Diffusion NB's repo. The first thing we'll look at is Stable Diffusion. So a couple of options here. You can clone this repo, which is linked from both course.fast.ai and the forum, and run it on a paper-based gradient or your own machine or whatever. Or you can head over to Colab, and you can just say GitHub, right? And then you can paste in the link to it directly from GitHub. Right?
Interesting.
And you can just say GitHub, right? And then you can paste in the link.
Oh my God, I totally even forgot about this, man. Actually, I also need to set up Jupyter notebooks locally.
Okay, so I'm running it on my own machine. And this notebook is largely being built thanks to the wonderful folks at Hugging Face. And Hugging Face have a library called diffusers. So any of you that have done part 1 of the course will be very familiar with Hugging Face. We use a lot of their libraries in part 1. Diffusers is their library for doing Stable Diffusion and stuff like Stable Diffusion. At the moment, these things are changing a lot, but at the moment, this is our recommended library for doing this stuff, and it's what we'll be using in this course. Maybe by the time you watch this, there'll be lots of other options, so again, keep an eye on course.fast.ai. In general, Hugging Face has done a really good job of being at and staying at the kind of head of the pack around models in general, deep learning. So it would be not surprising if they continue to be the best option quite a while. But the basic idea of any library is pretty similar. So to get started playing with this, you will need to log in to Hugging Face. So if you go to Hugging Face, you create a username there, a password, and then log in. Once you've done it once, it'll save it on your computer, so you won't have to log in again. And the thing we're going to be working with is pipelines, and in particular the Stable Diffusion pipeline. Again, you might be using different pipelines by the time that you watch this. But the basic idea of a pipeline is quite similar to what we call a learner in FastAI, which is it's got a whole bunch of things in it, a bunch of processing and models and inference all happening automatically. And just like you can save a pipeline in save a learner in FastAI, you can save a pipeline in diffusers. Now something that you can do in pretty much all Hugging Face libraries you can't do in FastAI is you can then save a pipeline or whatever back up into the cloud onto Hugging Face, they call it Hub. And so then we say from pre-trained, it's a lot like how we create pre-trained learners in FastAI, but the thing we put here is actually, if it's not on a local path, it's a Hugging Face repo. So if we search Hugging Face for this, then you can see this is what's going to download. And you can actually save your own pipelines up to the hub for other people to use. So I think this is a very nice feature that helps the community build stuff. So this is actually going to, the first time you run this, it's going to download many gigabytes of data from the internet. This is one of the slight challenges with using this on Colab, is every time you use Colab, everything gets thrown away and starts from scratch, so it'll all have to be downloaded every time you use Colab. If you use something like Paperspace, or particularly actually Lab Labs, it's all going to be saved for you. So once you've downloaded all this, it's going to save a whole bunch of stuff into your .cache in your home directory. So that's where Hugging Face puts things. So now that we have a pipeline called pipe, we can now treat it as a function, which is pretty common for like PyTorchy stuff and FastAI stuff. You should be very familiar with this, hopefully. And you can pass it a prompt. And so this is just some text. And that's going to return some images. Since we're only passing one prompt, it's going to return one image, so we're indexing not images. And when we run it, it takes, maybe 30 seconds or so, and it returns a photograph of an astronaut riding a horse. Every time you call a pipeline using the same random seed, you'll get the same image. You can set them as a random seed manually, and so you can send somebody else and say, oh, this is a really cool astronaut riding a horse I found. Try manual seed 1024. And you'll get back this particular astronaut riding a horse. So that's how you can, that's the most basic way to get started. Running on Colab or on your own machine, you can start creating images. It takes, as I said, 30 seconds or so, and in this case, it took 51 steps. What it's doing is a bit very different to like what we used to with inference in FastAI, where it's one step to classify something, for example. What it's doing in these 51 steps is it's starting with like, so this is actually an example that we're going to create ourselves in the course of creating handwritten digits, and this is actually an image from a notebook we'll be building. Well, we basically start with random noise, and each step tries to make it slightly less noisy and slightly more like the thing we want. And so going down here is showing all the steps to create the first 4, for example, or here to create the first 1. And if you look closely, you can kind of see in this noise there is something that looks a bit like 1, and so kind of decides to focus on that. And so that's how these diffusion models basically work. So if you have any trouble finding the materials we're looking at, to go to course.fast.ai or go to the forum topic to see all the links. And this one is called diffusion-NVs. And the notebook is called, you can see at the top, Stable DIffusion. Now, a question might be, well, why don't we just do it in one go? And we can do it in one go, but if you try to do it in one go, it doesn't do a very good job. These models aren't, as I speak now, in October 2022, smart enough to do it in one go. Now, as I mentioned at the start, the fact that I'm doing it in 51 steps here is, hopefully out of date, because as of yesterday, apparently we know how to do it 3 to 4 steps. I'm not sure if the code's available yet, so by the time you see this, this might be dramatically faster. But as I'll be describing, understanding this basic concept, I'm pretty confident it's going to be very important, like forever. So we'll talk about that. So if we do 16 steps instead of 51 steps, it looks a bit more like it, but still not amazing. Okay, so that's how you can kind of get started, and I'll show you a few things you can tune. And I should remind you that most of the stuff I'm showing you in this was built by Pedro Cuenca and other folks at Hugging Face. So huge thanks to them. There's no way I could have been as up to speed with all this detail without their help. They built this library to users and done a fantastic job of helping display what you do with it. So let's look at an example of what you could.
Alright, we're going to pause here. Be back tomorrow. I'm going to log off for now. So if you joined me today, thank you so much. Make sure to follow the channels. That way you can know when I'm going live, and I'll be live tomorrow. Right. Yeah, so that's all I have. Sorry, I just completely had a brain freeze. So yeah, let's stop here for today. I'll be back tomorrow, same time. Make sure to follow the channels, and I'll see you.